Hello everyone and welcome to the IT-KnowledgeBase YouTube channel, your ultimate destination for IT tutorials, troubleshooting guides, and in-depth tech insights. Whether you are an IT expert looking for advanced solutions or a beginner seeking to build a solid foundation in information technology, we have got you covered. Our channel offers step-by-step guides, review of the latest tech trends, and practical tips to help you stay ahead in the ever-changing IT landscape. Subscribe for regular updates and never miss out on essential IT knowledge. Using Linux, especially as a server, often means dealing with new errors and resolving them. Most of them are easy to fix with just a web search. However, some errors may require you to do some digging. In this training, I am sharing some Linux commands to help you diagnose and solve those Linux errors. Command number 1, dmessage. The dmessage command is used to display messages from the kernel ring buffer. This buffer contains messages that are generated by the kernel during system boot, hardware initialization, and when the system is running. It is particularly useful for diagnosing hardware issues, boot problems, and general system errors. Type dmessage. This displays all the kernel messages stored in the ring buffer. The dmessage command shows logs generated during system boot, which can help diagnose issues related to hardware or kernel initialization. This also filters messages using grep. You can filter the output to find specific logs. For example, to find messages related to network devices, just type dmessage space # grep ETH for Ethernet and hit enter. And check the filtered output specifically related to the Ethernet. If you wanted to show logs with timestamp, just type dmessage space -T and hit enter. This option converts the timestamp in the output into human readable format, date and time. By default, dmessage shows timestamps in seconds since the kernel started. If you wanted to see display only new messages, type dmessage space -W, hit enter. This option continuously displays our new kernel messages in real time as they are generated. It's useful for monitoring live system behavior such as hardware connections or disconnection. You can also limit the number of lines. You can limit the output to the last few lines. Type dmessage ~tail -n 50. This shows only the last 50 kernel messages. Dmessage logs hardware events such as when devices are connected or disconnected. It is often used to troubleshoot problems with drivers or hardware compatibility. To get information about memory allocation or issues, you can search for memory related messages. Type dmessage ~grep -I memory. Here you go, and filtered output specifically related to memory. You can also display them with human readable timestamp. This time you can see the output with the timestamp. So what are the common scenarios for using dmessage? Diagnosing boot problems. If the system is slow to boot or encounters errors during boot, dmessage can help you understand the underlying issues. Number 1, diagnosing boot problems. If the system is slow to boot or encounters errors during boot, dmessage can help you understand the underlying issues. Number 2, hardware issues. Use dmessage to check if devices like USB drives, network cards, or hard drives are being perfectly detected and initialized. Number 3, driver issues. If you are having issues with hardware drivers, for example graphics, networks, dmessage can provide useful debugging information. And number 4, kernel panic or crashes. In the event of a system crash or kernel panic, the messages in dmessage can help diagnose the root cause. So why you use dmessage? Debug hardware issues, identify hardware errors, missing drivers or failed hardware initializations, monitor kernel events, keep track of system events related to devices, network, memory and more. Diagnose boot issues, see kernel logs related to system boot for troubleshooting boot failures. Log real-time events, monitor live events like device plug, unplug or system errors using dmessage The dmessage command is a valuable tool for system administrators and users to debug and diagnose hardware, driver, and kernel related issues. Command number 2, systemctl. The systemctl command is used to control the systemd system and service manager. It allows you to manage and interact with system services, control system states, and query system's status. Let's see what are the key functions of systemctl is. I am running a few of my core services in this Ubuntu Linux box, and I have to continually monitor the random services to check the status of service. Let's say Apache 2 service. Type systemctl status Apache 2. Hit enter, and the service is active, which means it's running without any errors. If you need to start or stop a service, type systemctl stop Apache 2. To stop the Apache 2 service, hit enter. And if you need to start Apache 2 service, just type systemctl start Apache 2, hit enter to start the Apache 2 service. And if you need to restart a service, type systemctl restart Apache 2 and hit enter. The service has been restarted. Or if you need to set up a service to start automatically at boot or auto start the service, type systemctl enable Apache 2, hit enter. And if you need to set up a service to disable at boot, type systemctl disable Apache 2. For example, my Apache web server was not responding. I could check if the service is active. Systemctl status Apache 2. The status shows Apache 2 service is active, which means the service is up and running fine and there are no issues with the service. So why use systemctl? Number 1, for service management, you can easily manage services like start, stop, enable, disable on your system. Number 2, system state control. You can power off, reboot, and switch system run levels. Number 3, centralized control. Systemctl unifies system service control across systemd based distribution. Number 4, view logs. Check detailed log of services for troubleshooting purposes. Systemctl is a powerful tool for managing and controlling system services, system states, and target in Ubuntu and other systemd-based Linux distributions. It simplifies system administration tasks and provide unified command for managing system resources and states. Command number 3 is ps, report a snapshot of the current processes. The ps command allows you to display information about and monitor Linux processes. To get a detailed overview of all processes, run ps space aux. A means all process, U means user, and X means extended. It lists processes not attached to a terminal, such as system services. Hit enter. Now there is bunch of information. And now I would like to filter this output and should be restricted to the Apache 2 service. Type ps aux grep Apache 2 or any service you like. In this example, I would also filter out to SSH. And the output should come out with the precise filtered result. And if you want to list the processes in a hierarchical format, then run ps-H E. Hit enter. You can use the ps command to list processes with resource usage or to know a certain process ID. Command number 4, kill. The kill command is useful for forcefully terminating a running process. Sometimes multiple processes can conflict with each other, hence one process fails to execute. That's when you can kill the process causing the issue. To kill a process, you must know its process ID or PID. You can get the PID using the ps command and then kill the process by passing the PID to the kill command. How to find the process ID or PID? For example, to kill the Apache 2 process, first note the Apache 2 PID and run the command ps aux grep Apache 2. Note the PID number. Or you could also run the netstat command to get certain on the PID. Type netstat -antp pipe sign grep Apache 2, hit enter. And here is the PID of Apache 2 service 73786 and 73786, just to be sure. Now you know how to get the PID of any service. Now kill the Apache 2 service via kill command. Kill space PID number 73786 and hit enter. Verify if the Apache 2 service is running. The ps and netstat command. Type ps space aux pipe sign grep Apache 2, hit enter. Now there is no PID with this number. To be sure, netstat-antp -grep Apache 2. Apache 2 is not running. Now you can quickly start the Apache 2 service again if it is stopped or killed with the systemctl command. Type systemctl start Apache 2 ps grep Apache 2 to be verify whether Apache 2 service is up and running. Yes, with the newly generated PID. Or to be sure, type netstat-antp pipe sign grep Apache 2. Yes, Apache 2 service is alive again. And by the way, as you can see, I am using the root account just to eliminate typing the sudo command constantly. But you may also need to type sudo from the beginning of the commands only if you are logged in with the sudo or permitted user account. Command number 5, ping. The ping command in Ubuntu and Linux in general is used to test network connectivity between your system and a remote host. It sends ICMP, Internet Control Message Protocol, echo request packet to the target and listens for echo reply messages. Here's the basic syntax and some commonly used switches. Let's check few ping examples with tweaks. Type ping space -c 4 and the hostname. -c or count sends a specific number of ping requests. Hit enter. Second example is ping -i to remote hostname. -i or interval sets the interval in seconds between sending packets. Default is 1 second. Now identify the intervals between the ICMP sequence. Press Ctrl C to stop. Third example is ping -w 5 and remote hostname. -w or timeout sets the total time to wait for responses in seconds. Hit enter. Another example is ping -s 64 and the remote hostname. The -s or size specify the size of the packet to be sent in bytes. Hit enter. And it's sending a 64 bytes. Ctrl C for stop. Next example is ping -q and remote hostname. -q or quiet mode only shows summary statistics. That's all, not more than this. Ctrl C. Another example is ping -t 10 and remote hostname. -t or TTL sets the time to live value for the packets. TTL defines how many hops or routers the packets can pass before being discarded. Hit enter. Ctrl C for stop. Next example is ping -f and the remote hostname. -f or flood ping sends packets as fast as possible, useful for testing under load, requires super user privileges. Hit enter. You can see the flood stress. Control C to stop. Next example is ping -L 5 and the remote host name. -L or preload sends a specific number of ping requests without waiting for replies. Alright, Control C. Next example is ping -D and the remote host name. Capital D actually prints timestamp before each ping reply. Hit enter, and here is the timestamp. Next example is ping -R and the remote host name. Capital R actually records the route of the packets. Hit enter. Control C for stop. Now combine the key switches. To ping google.com with 4 packets, and a packet size should be 128 bytes and a 2-second interval between each ping. Type ping -C, count is 4, -S, packet size should be 128, -I for interval should be 2, and google.com. Hit enter. Now identify the intervals between the ICMP sequences. So this is all about ping. Stated switches allow you to control how ping operates, making it a flexible tool for network diagnostics. Command number 6, lsof. In Ubuntu and other Linux-based systems, the lsof commands stands for list open files. It is a powerful utility that displays information about files that are currently open by processes. Since everything in Linux is treated as a file, including sockets, directories, devices, etc., lsof can be used to monitor various types of resources. Here are some common uses of the lsof command. If you want to see files open related to the network, list all network connections, type lsof space -I, and this is list of all network connections. And if you want to see the files open in a specific directory, then use lsof space plus capital D /var/log. Hit enter. There are various files opened by different commands. And just to filter it out with the Apache 2, repeat the previous command and type grep Apache 2. Hit enter. Find which process is using a specific files or locking a file. Type lsof /var/log/auth.log. Hit enter. And here is a process of a specific file or locking a file. Find which process is using a specific port. For example, lsof space -I space :80. Hit enter. This will show processes using port 80 or commonly used for HTTP, and in this example, Apache 2 is using port 80. Another example is lsof space -I :22. Hit enter. This will show process using port 22, commonly used for SSH, and SSHD is using port 22. Next example is list open files for a specific user. Type lsof -u and the username is nmam. Hit enter. Here you have a long list of the processes opened by the specified user. Now show all open files by a specific process, but first note down the PID number of the process. Again, type the ps aux grep Apache 2, and here is the process ID. Now type lsof -p /74133. Hit enter. And this is the all open files by a specific process. Next command is display files opened by a specific application. Type lsof -c Apache 2. Hit enter. And these are the files opened by Apache 2. So this is all about LSOF. Is commonly used for troubleshooting, such as detecting which processes are using a certain resource or port, identifying network connections, or finding files logged by processes. Command number 7, grep. The grep command is useful for searching for string and patterns through files and whole directories. In my previous commands, I had used the grep command rarely earlier, with the combination to filter out and search for the specific service or text. To do a simple search, you pass the pattern and the file name or directory to the grep command. I am changing my prompt to my data directory, which is cd /data, and list the directory. We have created 3 files in the data directory. Now search the text within the file. Type grep -i. In this example, I would like to search training in the cisco.txt file. Or you could search the pattern within the directory for common words. For example, grep -r, pattern is training /data, hit enter. And this is the pattern or common word search in the directory. Suppose you have log files with thousands of entries. The grep command will help you search for lines relevant to your problems. You may also search for common words such as error or failed to find the lines quickly. You can also pipe the output of another command to grep like this: cat var log file auth pipesign grep ssh. This is my log file with thousands of entries, and the grep command will help me to search for lines ssh or search for common words such as ssh, and it finds the line quickly. Now let's check some basic examples. Search text in a file. In this example, I would like to grep software in the cisco.txt file. This will search for the terms software in the file cisco.txt and display any matches lines. Search for text in multiple files. Repeat the same command. File number 1 is cisco.txt and the file number 2 is microsoft.txt. This search for software in both files, file number 1 and file number 2. Now search recursively in all files in a directory. Grep -r software directory name. The -r or recursive flag tells grep to search through all files in the specified directory and subdirectories. Case insensitive search. Grep -i, type cisco in the cisco.txt file. Linux is case sensitive and the -i option makes the search case insensitive. So it matches both uppercase and lowercase variations. Next example is display line number for matching lines. Grep -n, type search pattern is training. File is cisco.txt, microsoft.txt and linux.txt. Hit enter. The -n option will show the line number of each matching line in the output. Next example is show count of matching lines. Type grep -c, type online in the cisco.txt, microsoft.txt and linux.txt. The -c option will count and display the number of lines that match the search term. Another example is search for lines that do not match a pattern. Grep -v, online in the cisco.txt file, microsoft.txt and linux.txt file. The -v option inverts the match, showing lines that do not contain the search term. Search using regular expressions. Type grep online.wildcard in the linux.txt. Grep can interpret regular expressions or patterns. In this example, it searches for lines starting with pattern followed by any characters with dot wildcard. Next example is search in the output of another command. Type ps aux pipe sign grep bash or grep ssh or grep apache 2. You can use grep in combination with other commands using pipe. In this case, it searches for bash, ssh and apache 2 in the list of running processes generated by ps-aux. Grep is incredibly versatile for searching through logs, configuration files or any other text-based data in Linux systems. It's a fundamental tool for troubleshooting and parsing data. Command number 8, tail. The tail command is used to display the last part of a file or data stream. By default, it shows the last 10 lines of a file, but it can be customized to display any number of lines or even follow live updates to a file. If you have a log file that are too long and you are only interested in the latest additions to the file, the tail becomes handy. You can also use the tail to actively monitor a log file. Here are some common uses of the tail command. To display the last 10 lines of a file, in this example, I am utterly pointing auth.log file. Type tail /var/log/auth.log. Hit enter. Here are the last 10 lines of the file for further authentication related investigations. Now specify the number of lines to display. Tail-n 20 and the file name is auth.log. Hit enter. This shows the last 20 lines of the file name. Now follow a file in real time, and this is very useful for real-time log monitoring. Type tail-f same auth.log file. Hit enter. The F option makes the tail continuously display new lines as they are added to the file. For example, monitoring a log file in real time. To make it a fact, the user nmam is taking an SSH into this machine, and here he logs in and then logs out. Ctrl C to stop. Next command is follow a file and limit the number of initial lines. Type tail-n space 20-f same auth file auth.log. Hit enter. This shows the last 20 lines and continues to follow the file for updates. Ctrl C to stop the process. Next command is display the last n bytes of a file. Type tail-c 100 var log auth.log. The -c option displays the last 100 bytes of the file. Now you can follow the multiple files. Type tail-f. File number 1 is auth.log and the file number 2 is syslog. Hit enter. This follows updates to both auth.log file and syslog simultaneously. Now the next example is terminate follow mode after a certain duration. First check the process ID you want to monitor. ps-aux grep apache 2. Note that PID, then run the tail command with its process ID. Tail-f var log auth.log -PID equals 74133. This is Apache service PID, and hit enter. This follows the file until the process with the given PID terminates. Open the separate terminal. And check the given PID is present. Type ps-aux grep 74133. Hit enter. Yes, the process is running. Now let's kill this PID. Type kill 74133 and hit enter. And it's terminated completely. Suppress headers when following multiple files. Type tail -q -f. Same auth file. Type var log syslog. Hit enter. The -q option suppresses file name headers when monitoring multiple files, and if you run the same command excluding -q, this shows as a separator or separate file output. I usually prefer to use -q for suppressions. So this is all about the tail command. Is particularly useful for reading log files, monitoring system processes, and debugging live issues by viewing the latest output from files as they are updated. The tail command can also be used to pipe the output of another command. Command number 9, journal CTL. The journal CTL command is used to query and display logs generated by the system, services, and applications. It provides a powerful way to view system logs, filter specific events, and troubleshoot issues. Here are some common uses of the journal CTL command. View the system logs. Type journal CTL. Hit enter. This displays all logs in chronological order. View the most recent logs. Type journal CTL -n 50. The -n option shows the last 50 log entries. Follow logs in real time. Type journal CTL -f. This will continuously display new log entries as they are written, and this is useful for monitoring logs in real time. View logs for a specific to boot. Journal CTL -b. This shows logs from the current boot session. To view logs from previous boot sessions, type journal CTL -b and -1. -1 refers to the previous boot. You can change the number to view older boots like -2 or -3, etc. View logs for a specific service. Type journal CTL -u and SSH. This is all about SSH. This is a failed password for route from this source to destination. View logs within a specific time range. Type journal CTL -since and the date and time. This shows logs between 10 a.m. and 12 p.m. on September 17, 2024. Hit enter. Here is the detailed logs. You can also view the logs in the last 1 hour. View logs by priority level, for example, error or warning. Type journal CTL -p. Type ERR or error. This shows logs with an error priority, and other priority levels includes emergency, EMERG or emergency. There is no emergency logs. Another priority level is alert. There is no alert. Another is critical, CRIT. There is a critical logs. Next one is warning. There is a warnings. Another one is notice. Yes, there is a notice. Next priority level is info. There are information. And the debug. View log for a specific process. Type journal CTL _PID equals 1234. There is no entry. Then search for the PID. PSAUX space space pipes and grep SSH. Now search the journal CTL _PID equals 70871, the process ID of SSH, And in this example, we are actually viewing logs for a specific process by its process ID. Now check the kernel logs. Journal ctl-k. This shows logs related to the Linux kernel. Now show logs in reverse order. Journal ctl-r. This shows the most recent logs first in reverse order. Limit output to a certain number of lines. Journal ctl-n100. This will only show the last 100 lines of logs. Display logs with a specific message. Type journal ctl #grep ssh. You can use grep to search for a specific term within the logs. View logs for a specific user. Type journal ctl _ uid equals 1000. You can check the UID of a user in the password file. Type cat etc password, and here is the UID. Next example is clear the systemd journal logs. Hit enter. This clear logs older than 2 weeks to free up some space. Check disk usage by logs. This shows how much disk space the logs are consuming. This is all about the journal ctl command. It is extremely useful for system administrators and developers for monitoring services, debugging issues, and reviewing system events. It provides more flexibility and detail compared to older logging systems like syslog. Command number 10, strace. The strace command is a powerful debugging tool that allows you to trace systems calls and signals made by a program or process. It is often used for troubleshooting, debugging, and understanding how our programs interact with the operating systems. Now trace system calls made by a command. Type strace space ls command. This shows the system calls made by the ls command. Now attaching to a running process, type psaux Apache 2. Now type strace -p and the PID of service. Hit enter. The -p option attaches strace to an already running process by specifying its process ID. Next example is trace system calls related to file operations. Type strace -e. Trace equals open, read, write space ls. This will trace only open, read, and write system calls. Now how to follow the child process? Type strace -f space ls. Hit enter. The -f option ensures that strace follows and traces any child processes created by the original process. This is useful for programs that spawn other processes. Next example is trace network related system calls. Type strace -e. Trace equals network space ls. This trace only system calls related to network operations, for example socket, connect, send, and receive. Log output to a file. Type strace space -o and output file name. Here is the output file. Next example is timestamp each system call. Type strace -t and ls. The -t option will print a timestamp before each system call. Another example is measure time spent in each system call. The -t option displays the time spent in each system call, which can help identify performance bottlenecks. Next example is summarize system calls statistics. The -c option runs the command and provides a summary of how many times each system call was made and how much time was spent in each call. Next example is intercept and display signals. This command strace-e trace equals signal and ls. This traces signals sent to the processes, for example, signal term or signal kill. And the last example is tracing a program. Let's say you are trying to figure out why a program is failing to open a file. Type strace-e trace equals open and the program name. This command will show you all the open system calls made by the program and can help you identify missing or incorrect file path. I don't have any program right now, but you should get an idea how to check any program. In summary, strace is a powerful tool for developers and system administrators to diagnose issues related to system calls, file operations, network connections, and more. If a program happens to be hanging and you can't find the reason, you can trace the system calls the program is making and reveal why it's getting stuck. Command number 11, htop. The htop command is an interactive process viewer that provides real-time information about system processes, similar to the traditional top command, but with a more user-friendly interface and additional features. Type htop. What is the key feature of htop? It's a real-time system performance monitoring. It displays CPU usage for multiple cores, memory usage and swap usage, provides a visual representation of system resources consumptions with bars. It also details process information, lists running processes with details such as PID or process ID, CPU and memory usage, and command line. You can also scroll both vertically and horizontally to view more processes or details columns. htop is interactive interface. You can use a keyboard or mouse to select and interact with processes. Unlike top, htop allows for easy filtering, sorting, and process management, showing a live view of system processes. Sort processes by different metrics. Press F5. Shows processes in a hierarchical parent-child view. You can also press F6 to sort processes by various metrics such as CPU, memory, PID, etc. Again press F6 and sort by user. Then press F6 again and sort by priority. You can also use arrow keys to navigate between processes. Search for a process, press F3. To search for a specific process by name or keyword, type SSH. This is SSH process, or type Apache 2. This is Apache 2. You can also filter out processes, press F4. To filter the disparate process by keyword, I would like to filter with the SSH or filtered by Apache 2. These all the filters for Apache. You can also kill a process. Select a process using the arrow key and press F9 to send a kill signal or signal term. You can select different signals, for example sig kill or signal kill to force termination, and the process is killed. Press F1 to view detailed process information. You can also press F7 to decrease and F8 to increase a process priority nice value. Press F2 to open the setup menu where you can customize what information is displayed, for example change columns, colors, meters, etc. Press F5 to view the process in a hierarchical structure, parent-child relationship. You can also use the mouse or the arrow keys to move to different columns and press enter to sort processes by that column, for example CPU usage or memory, etc. You can sort processes by memory usage by pressing F6. You can also view user-specific process. Type htop -u and the username nmam. This shows processes running under a specific user. You can also display only processes owned by a specific user. Type htop -user equals nmam, and this is the only processes owned by a specific user. Why use htop? It's a user-friendly interface. It's easier to navigate and understand than top, with mouse support and colorful visualizations. Advanced features: you can scroll through the list of processes, search, filter, scale processes, and view hierarchical structure of processes. It provides real-time CPU, memory, and swap usage information. Top is customizable. You can configure which columns to display, set processes priorities, and more, all from within the interface. In summary, HTOP is a highly efficient, user-friendly tool for monitoring system processes and performance, making it ideal for system administrators, developers, and users who need a quick overview of system resources usage. Command number 12, df. The df command is used to report the amount of disk space used and available on the mounted file system. It provides a quick overview of how much storage space is available on your system's partition. To check basic disk space usage, type df and hit enter. This command displays the available and used disk space on all mounted file systems. You can also use -h for human readable format. The -h option formats the output in a more readable way, showing sizes in KB, MB or GB instead of our raw blocks. You can also show disk usage of a specific file system or directory. Type df and the folder name. This will show the disk space usage for the specific mount point or file system associated with the directory. You can also run the df command with the -T. This option shows the type of each file system, for example ext4 or tempfs. df-i. The -i option shows inode usage instead of block usage. Inode represent file metadata, and it's possible for a file system to run out of inode even if there is space available. Type df-k. The -k option shows the size in kilobytes. Other option includes -m for megabytes and -g for gigabyte. df-l. This option restricts the output to only local file system, excluding network mounted ones. df-a. The -a option includes all file systems, even ones with 0 blocks, like a special pseudo file system. df-h. The example of output, the file system, the name of the device or mount point. In the size column, total size of the file system, the amount of space currently used, the amount of available space, use %. This shows percentage of used space mounted on the mount point where the file system is attached. So why we use df? To check available disk space, quickly see how much space is left on your system or a specific mount point. It also monitors inodes usage, helps identify if your system is running low on inodes, which can prevent creating new files even if there is space available. It also identifies full partitions, helps detect when a partition is running out of space, which can cause system issues. In summary, df is a simple and effective tool for monitoring disk space usage on Ubuntu and other Linux systems, making it useful for systems management and troubleshooting. Command number 13. Free. The free command is used to display information about the system's memory usage. This includes both physical memory and swap memory. It provides a quick snapshot of how much memory is used, free and available for processes. To check basic memory usage, type free and hit enter. This shows the total used and free memory in the system in terms of kilobytes by default. For human readable, type free space -h. -h option displays the memory in a more human readable format using units like kilobytes, megabytes or gigabytes. Let's understand the column. Total, it shows total physical memory available. Memory currently in use by processes. Free, memory not being used. Memory used by processes running in shared memory. Buffer or cache, memory used by the system or buffering and caching data. Available, the actual amount of memory available for new processes without requiring the system to swap. Second is swap. In the swap, total column speaks about total swap space available, swap space currently in used, and available swap space. You can also display memory in bytes, kilobytes, megabytes, or gigabytes. Type free-b. It displays in bytes. Type free-k. It also displays in kilobytes. Type is free space -m. It displays in megabytes. And -g. It displays memory in gigabytes. These options allows you to specify the unit for displaying memory usage. To show memory in terms of buffer and cache, type free space -b. This shows how much memory is used, but also separates out how much memory is being used by the kernel for buffering and caching. Next command is free-s and space 5. The -s option displays memory information every 5 seconds or the interval you specify. Free-w. This shows the detailed memory usage statistics, including memory that's freed from the buffer or cache. So why use free command? To check available RAM, see how much memory is currently free and available for use. Monitor swap usage, track how much swap space is being used and how much is available. View cache and buffer memory, understand how much memory is being used by the system for caching and buffers, which can give insight into system performance. In summary, the free command is a simple and effective way to quickly check system memory usage in Ubuntu, helping with performance monitoring, troubleshooting, and understanding system resources allocation. Command number 14, ls cpu. The ls cpu command is used to display detailed information about the CPU architecture and the system's processors. This command provides key details such as the number of CPUs, cores, threads, architecture type, and more. Type ls cpu and hit enter. The key information displayed by ls cpu is the architecture, shows whether the system is 32-bit or 64-bit. The CPUs display the total number of logical CPUs or threads available. Cores per socket, the number of CPU cores per physical CPU socket. Threads per core, the number of threads supported per core, helpful for understanding if hyperthreading is enabled. Sockets, the number of physical CPU sockets on the machine. CPU megahertz displays the current clock speed of the CPU in megahertz. Cache size displays the size of the CPU's L1, L2 and L3 caches. Vendor ID shows the manufacturer of the CPU, for example Intel or AMD. Model name, the specific model of the CPU, for example Intel or AMD. ls CPU also displays various CPU flags which represent supported CPU features like virtualization, VMX for Intel or SVM for AMD, 64-bit support LM and more. You can also get other information such as your CPU capabilities, virtualization features and vulnerabilities. Learning these important Linux commands has not only helps become a better troubleshooter, but also deepen understanding of Linux systems operations. These commands are diverse in nature, so no matter what kind of problems you might be facing, this will come in handy. Alright, that is all for the now. Thank you for watching and I look forward to sharing more of my journey with you all. If you want to see more awesome training content, make sure you click that subscribe button. Click it so you don't miss it. Or if you have any issues or questions, you can reach out to me and I'd be happy to help you out. Thank you.